Sign charts are going to be a very important tool in calculus. Depending on what you did for pre-calculus, you maybe feel very comfortable with sign charts, or you maybe have never seen them before at all. But what a sign chart is really just a number line, and it helps us to solve inequalities. So if I have something like x minus 9 is less than or equal to 0, what we do is look at the expression over here, x minus 9, and identify all of the zeros of that expression. Well, in this case, there's only one. It happens at 9. And 9 is the point that's going to make this expression equal to 0. So I'm going to put a little dot there for equaling 0. And what this is a sign chart. We are trying to identify the sign of that expression everywhere on the number line. And how we do that is just test a couple numbers. We pick a number that's down here smaller than 9, so anything, like maybe I pick 0, and test it. 0 minus 9, that's negative 9. I really don't care what the number is, I care about the sign. This is a sign chart, not a number chart. So the sign of that number is going to be negative. In fact, every number on this interval, any number less than 9, is going to give us a value that's negative. And when we do the same thing on the other side, pick a number that's over here, and maybe this time I pick 100, and I put 100 in there. 100 minus 9 is 91. I don't care about the 91 part, all I care is that's positive. Now that we have this sign chart completed, what it tells us is that every value less than 9 is going to make that expression negative. And every x value that's greater than 9 is going to make that expression positive. So, in order to answer the question, we go back to the question. I want to know when is x minus 9, our expression, less than 0. So really, I'm asking, when is it negative? Okay. Well, look at your sign chart. It's negative over here when x is less than or equal to 9. Now that's an obvious one that you did not need a sign chart to solve. But I want to start easy with you so you can see how a sign chart works. When we have more than one factor, like x plus 5 times x minus 4 is less than or equal to 0, we have to identify all of the zeros. And x plus 5 has a 0 of negative 5. And x minus 4 has a 0 of positive 4. These are the values that are going to make the expression equal to 0. Next, we go through and test each interval. So we pick a number here that's smaller than negative 5, like negative 100. Okay. If I do negative 100 plus 5 and negative 100 minus 4, I really don't care what their values are. All I care about is their sign. And negative 100 plus 5 is negative. Negative 100 minus 4 is negative. So I'm going to take this negative number and multiply it by another negative number. That's going to give me a positive number. So every x value that's smaller than negative 5 is going to make the product positive. Next, we test the next interval. Pick a number that's in between here, like 0. 0 plus 5 is going to be a positive number. 0 minus 4 is a negative number. A positive number times a negative number is negative. And then finally, picking a number that's greater than 4, like a billion. A billion plus 5 is positive. And a billion minus 4 is positive as well. Positive times positive is positive. Now, to answer the question, go back and read it. I want to know, when is the expression less than 0? It'll be less than or equal to 0 when it's negative. So look to the sign chart. When is it negative? On this interval, when x's are on the interval from negative 5 to 4. Or if you want to write it as a compound inequality, you could do that as well. Sometimes we're going to have to do a little extra work. When we have x squared minus 36 is greater than 0, we want to factor it. Luckily, this is a nice one. Difference of two squares, x plus 6, x minus 6, is greater than 0. So our two most important numbers are going to be negative 6 and positive 6. Those are where the function is equal to 0, or the expression is equal to 0. testing each interval. Just go through, pick a number that's smaller than -6, like -100. -100 plus 6 is negative. -100 minus 6 is negative. So when we do negative times negative, that will be positive. As we continue, picking a number in between, like 0. 0 plus 6 is positive. 0 minus 6 is negative, so that product is negative. And then picking a number larger than 6, like 2 billion. 2 billion plus 6 is positive. 2 billion minus 6 is positive. Positive times positive is positive. Now, what do we want? Go back to the question. I want to know when the expression is strictly greater than 0. Well, that's going to happen when it's positive. So when x is less than -6 or when x is greater than 6. Not equal to this time, because we're not allowed to equal 0. When you have an inequality that is not greater than or equal to 0, then a sign chart isn't helpful. So the work that we have to do first is to get the expression to be compared to 0. Then we know what's positive or negative. And this one will act a lot like the last one. We factor it, x plus 5 and minus 5. So -5, +5. Testing a couple points. Negative 1 billion. That would leave us with negative and negative, so positive. 0 would leave us with positive and negative, so negative. And 1 billion would leave us positive and positive, which is positive. We want the ones that are greater than 0. We see that right here. And so our intervals, again, are less than -5 or greater than 5. Here we have a big one, a cubic function, x cubed minus x squared minus 4x plus 4, less than 0. We have to factor this. So we should go about using any technique we got to factor it. I'm going to factor it by parts. And on the front side, I can take out an x squared, and I'm left with x minus 1. On the second part, I can take out a -4, and I'm left with x minus 1. So we factor out the x minus 1, left with x squared minus 4, so we factor that again. X minus 1, x plus 2, x minus 2. So this cubic function has 3 different factors, and we can see all of them. We have a factor of -2, of +1, and +2. All of these will make the function equal to 0. But now that we have 3 factors, 3 zeros, that means 4 intervals. So we test a number that's smaller than -2, like -1 billion. That would leave us with -1 billion and 1, -1 billion plus 2, and -1 billion minus 2. Negative times negative times negative is negative. When we pick one that's in between, -2 and 1, that'd be 0. 0 minus 1 is negative. 0 plus 2 is positive, and 0 minus 2 is negative. Negative times positive times negative is positive. In between 1 and 2, like 1 1/2. 1 1/2 minus 1 leaves us with a half. That's positive. 1 1/2 plus 2 is 3 1/2. That's positive. 1 1/2 minus 2 is -1/2. That's negative. Positive times negative is negative. Finally, as we pass over 2, I hope you see the pattern here that, take even a number like 10. 10 minus 1 is positive. 10 plus 2, positive. 10 minus 2, positive. That now the final factor had turned positive. Everything is positive, so the product is positive. Which one do we want? We go back to the problem. We want to know when it's less than 0. That would be the negative ones here and here. So when x is less than -2, or when it's in between 1 and 2. But that's how you use a sign chart to solve really just some basic ones. As we continue, we'll see much more complicated, much more interesting inequalities to deal with.